Get into this one. How it is equilibrium possible? Is it possible? First of all, yes. I gave some rough diagram. You have to put that orientation is asking that alpha. For our convenient, so let's do one thing. We'll give name. This is A. The base. It's not a semicircular plate. Please, I am writing shell. That blue color dotted line is what? Parallel to inclined plane. It's telling an equilibrium. So what is the basic idea of the equilibrium? What is the basic idea of equilibrium? The net force, the net torque should be zero. Okay, let's do one thing. We'll get into the weight, how the weight will act vertically down. Then component of weight will act along the incline. Then who should balance? The friction only. So the friction should act up the incline. There's the one thing. Next after this, normal contact. How the normal contact should act? Perpendicular to inclined plane. For a spherical object, what should be the direction of normal contact? Along common normal, along its radius vector. So now this particular shell under action of normal contact, friction and weight is in equilibrium. So therefore the net torque should be zero. About which point? About any point on the shell or about any point on the inclined plane. And the net force along the incline perpendicular must be zero, or net force along x along y must be zero. I think the problem, it's all about the drawing diagram, nothing to do with the physics much here. So straight away, I'll conclude in a very simple way here. You have to fight with the diagram. The question should be analyzed through the diagram. Let me. There's a hemisphere, no? Okay, this is the inclined plane. Some rough diagram, I'm presenting it in this way. Okay, let's come for. This is a radius vector, and this should also be radius vector. And this angle is 30 degrees. This is the A, B, and the hemisphere will be in contact with the inclined plane at point P. Where the center of mass of hemisphere should be. At mg, at r by 2. Okay, still I do. Not looks like hemisphere. I'm drawing some. It's hemisphere only, may not appear, but it's hemisphere only. Yeah, fine. So this is the where the center of mass should come here at r by 2, and how do it will act? It will act vertically down. The weight mg will act vertically down. So shall I put in this direction the weight mg? Then how the normal contact? Normal contact should act along radius vector. So this should be the n. Then how the friction? Friction should act along the incline. The equilibrium is possible only under this assumption. O is the radius of O is the center of that AB. So this distance is r. This is also r.
Right.
No, you don't ask any question. Please think it here. Don't ask any question. There's no necessity of asking any question. Just you have to think in this all. Okay, let's get into the problem. Uh, so you can ask question, why you are assuming? You do one thing, draw the diagram, place it in some way. The net torque will be zero when the point of application means, so if all the forces, if their point of application pass through a point, then only what happens, the net torque can be zero. Otherwise, not possible. So then sir, O will balance friction component of mg, and the O will balance normal contact component of mg. I think I am satisfying all the things. Net force on the system perpendicular to incline, parallel to incline is zero, and the net torque is zero because what about point P, the net torque is zero. Sir, what about point 2? Torque due to mg and f will be equal and opposite. Sir, what about point A? Torque due to all three will be, the resultant torque due to all three forces will be zero. So this is what happens for the orientation. So now can we take this angle? So some beta, I'll call it. What is sine beta or cos beta? (60°). So he's asking that orientation. So what shall I put? Alpha, angle made by the base AB with inclined plane. Hemispherical shell, R by 2. Hemisphere, I think solid hemisphere. If you cut lemon into two equal parts, hemisphere, when you squeeze juice out of it, will become hemispherical shell. Geometry, basic geometry. Okay, now shall I put what should be the alpha? Answer alpha. Anybody? Alpha. 60°. The orientation for equilibrium. It's a diagram based problem. Come for next one. There's a rod